what's going on there. I don't even know there was such a
Yeah.
thing as Pascal.
But Pascal is just another way of expanding something like this. Like for example, you know this how to expand this, right? It's a squared plus 2ab plus b squared. You know it from high school, right?
Yes,
Pascal says,
taking out the bracket.
yeah. But if like there's a 10 here or 20, it becomes more difficult because we were only taught, I think, this and the other one, this one. This one, I think it was a squared plus, oh, sorry, a3 plus 3 a squared b plus 3 a b squared plus b3. We were taught something like this. I'm gonna come back to
Oh,
this.
okay.
I'm gonna come back to it. Pascal, basically, you put a 1. You just create a triangle. You start by putting a 1. And then below the 1, you're gonna put 1 on the left-hand side and put 1 on the right-hand side.
Mm-hmm.
Yeah. And then you're gonna do the same thing. You're gonna do the same thing. Wait, I'm gonna check something. Oh, you're gonna do the same thing with these other 2 ones. But first you need to add them because now there's 2 ones. When you add them, what do you get? You get 2. The 2 you're gonna put the 2 below both of them, in between. And
Right.
the next line is this is line 1. I call it line 0 actually. And this is gonna be line 1. And then line 2. Like that. So here, line 2, when you add 1 and 1, you get 2. Right?
Mm-hmm.
And then you're gonna put a 1 next to this, just like you did before. And the same thing here, you're gonna put a 1. And then you go to the next line. 2 plus 1, what is it? That's
3.
that's gonna be line 3, or we should call it n. This is gonna be n. That's if we say a plus b to the power n. So this is your n. And then we're just gonna put a 1 next to the other. Then we add 1 and 2, we get 3. We add 2 and 1, we get 3.
Mm-hmm.
Then we put 1 on the other side. And then you just continue because they said 5 then. Let me just show you this one. We're at 3. So if I had to use Pascal to expand this thing, I would say a plus b 3 is equal to the first. These are the coefficients. The coefficients
Okay.
of the whole answer here. See, there's 1, 2, 3, 4 terms. You see here 1, 2, 3, 4.
Mm-hmm.
And then you look at the first coefficient is 1. And then you put the a. The a will have maximum 3, but it keeps on decreasing. And then you put b here. The b would be 0, such that when you add 3 plus 0, you're gonna get 3. You must always get this 3.
Okay.
But then b0 is like 1, which is why you don't see it here in the answer. Plus, then you take this coefficient 3 a. Now this a, this first term here,
Mm-hmm.
it reduces by 1. It becomes 2. And then the next term increases by 1. Look at the coefficients. 2 plus 1, always 3. And then you move on, you take this coefficient, sorry, this one, 3, and then you continue with the a here, the first term. It reduces by 1, it's going to be 1. And then the other one increases by 1, it's going to be 2. Then the last one is going to be 1. Then a now will be 0. Then b will be 3. Then if you clean it up, that's how it ends up being 3a squared b plus 3a b squared plus b3. Yeah.
Yes.
So, oops. Oh man, I'm trying to move this thing. So, if we continue this Pascal thing, let me just do another one here. 2, put another one here, put another one here. It's gonna be 3 here, gonna be 3 here, and then put 1 on the side. And then here it's gonna be 4. It's gonna be 6. It's gonna be 4. Put 1. Put 1. Then we do it again because we want 5. This is 0, 1, 2, 3, 4, 5. This is gonna be 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1 is 5. And then, so this will be the coefficients when n is equal to 5. This one.
Oh, it makes a lot more sense now.
So, which is why, I don't know if I should write it again, but maybe I should. I will just maybe write 2 lines and then explain the whole thing. We had cosine theta plus sine theta all to the power 5. This is the one we're focusing on because we want to equate the page ran away.
So is it gonna be shorter since we're using, if we're gonna use like Pascal's, the one with the head?
Yeah, it's gonna be shorter. It's gonna be short.
Oh, okay.
There's no other way, right? There's no other way. It's we said it's cos 5 theta plus I sine 5 theta. And we are interested in this. So we need to expand this because you can see this one, it doesn't have a it doesn't have a 5, and the question asked us to express this as cos theta. So we need to expand this thing so that it becomes our answer somehow. The one that doesn't have I, the one that has I, it will be the answer for sine 5 theta. But yeah, but to make it easier, let's just turn this cos theta to A, and then I, B, right? You know the back of your mind that A is cosine. When you express at the end, you just replace. Then we said this one was 1. Then A, the first term to the power 5. B to the power 0. And then the next one was what? Let me check again. Was 5, 10, 10, 5. So the next one will be 5, the coefficient. And then you write the A, we reduce it by 1. The B increases. Oh, sorry, I made a mistake here. It's not actually B only. It's the whole thing here.
The IB, yeah.
Yeah, the I and the B. And we can just put it in a bracket. The I and the B to the power 1. Plus, I think it was 10. Then A to the power 3. I, B to the power 2. Plus 10. A to the power 2. I, B to the power 3. And plus 5, né? 5 what? A1 IB4, and the last one was 1. So we're not gonna write that. Okay, we just write it. A0, just write the 0. Then IB5. And then I'm not gonna write it. I'm just gonna show you what I did here because I already did it. I've already done it. So I'm just gonna Then I just expanded, like, you know how to expand. Do you know how to expand?
Okay, yeah, now I see that because the day when I was going through it, it sort of didn't make sense. But I saw like things were like increasing and decreasing, but I didn't know how to get it there. So it makes sense now. So I'm just gonna
But
note
I doubt
that.
if we ask something like that, maybe you might put a 3 here or 2.
Oh, okay.
Because you know exams are timed, man. There isn't time to be doing such a
Oh, it's not gonna make it very long.
yeah, I'm not gonna make it very long. And then after expanding, can you see where I'm pointing?
Yes.
After expanding everything, you take like 10.
Okay.
You take like terms, and then all the items will be grouped together.
Mm-hmm.
So now this whole thing is equivalent to this whole thing, right?
Okay.
But the question asks us to express cos 5 theta. So we are only interested in this one that doesn't have an I.
So the only cost.
Yeah, because remember this thing is equivalent to this thing, so they are equal. So if they're equal, that means this is equal to this, and then the sine 5 theta is equal to this.
So we only take that first part.
Yeah, we're just gonna only take this one, and then we because we only want this thing to be in terms of what? Cosine. The reason why there's a b here, and b I said is a sine. So I changed, you know, sine squared, right? Just imagine this thing as sine squared. Sine squared can also be 1 minus cos squared.
Oh yeah, for the cos squared. It's the identity thing.
Identity thing, and then plus 5a, and then you do the same thing with 5b4.
Okay.
So it's gonna be like b2 to the power all raised to the power 2, and then b2 we said is this thing, and then it's just a matter of replacing the a, and you get the final answer. If the question had asked you for sine 5 theta, you will only choose this one.
Okay.
Yeah. Yeah, and then the last one is this one, very important. It's you need to, here I was trying to show you how they got these formulas, just in case you forget them in the exam.
Oh, it's the proof basically.
Yeah, it's the proof. It just all stems to this formula that I showed you previously. The Zn, Zn is equal to this thing raised to the power n. Because remember, Z is like a complex number. So a complex number, you can also write it in polar form. Just imagine the Z only has R is equal to 1. You can write it in polar form as this thing inside the brackets here. And then because it's raised to power n, we can put the n there. And then I also showed you that this exact formula is equivalent to this one here. Is equivalent to this one. And then you do the same thing with Z minus. Now you're replacing with minus, and you know when you have a negative inside the sign, you take it out. And when it's on when it's inside cosine, it doesn't change. It's still the same as positive. And then when you add these two z's, this one will go away. It will vanish. You will end up with 2 of these, which is what happened here. But if you subtract, only the cosine will go away, and you'll be left with because I'm subtracting this negative will cancel with the other negative. We'll be left with 2i. Don't forget the I here. Sine.
Okay.
And then if n is 1, it's a special case. It's just gonna be replacing 1 here, and you have this formula. But the most important one here is this one.
Okay, I'll take note of that.
Yeah, so this one comes, they ask, this is how they ask, express sine 3 theta in terms of sine k 5 theta. So you remember the first one, eh? The first one, the previous one, the one that you're coming from right now, it wanted you to express sine whatever k, in that case it was 5, into something that didn't have k, or k was 1. This one, you see, it's an exponent.
Okay.
It's an exponent, this one. If you see some exponent and then say express sine cube in terms of sine k theta, some number inside, you have to use those formulas I showed you. Otherwise, you won't be able, otherwise you won't be able to do the question. You have to kind of like memorize, okay, if it's cube, I mean, if it's an exponent and I have to remove the exponent and make it to is something that doesn't have an exponent, it's those formulas.
Okay.
But if they give you something that has a number multiplied by the argument, and then you have to remove that number, then it has to be Pascal, something with Pascal.
All right.
So in this case, we're dealing with sine. So sine, the formula for sine is this one, right? That's this one. So so we're gonna use this one because the reason why we're gonna use this one is because basically we are trying to get sine 3 cubed equal to something that doesn't have cube. So the only way we can come up with sine cube first, because we have to come up with that sign, just like we did, here. We had to come up with the cos 5 theta, and we know that, okay, cos 5 theta, it normally comes with sine. And then so we can, if we can write it like this, then we'll be able to come up with the cos 5 theta. So here it's like the same idea. We want to come up with this sine 3 theta so that we can express it in this format. So you choose this one, the one with 1. If it was cosine, you will do the same thing, but the other formula, the one with cosine, you choose this one.
Okay. So
after doing this, you realize, okay, the sine, it doesn't have a cube here, so it must have a cube. So you just gotta cube everything, what you do on the left, on the right. And then I showed you Pascal. It's the same idea here with this one.
Oh, okay.
The same idea, and it's just a matter of simplifying until you get to this clean step. This step is,
all right.
And then once you get to this step, you collect terms that have the same powers, degree powers. Like for example, Z3 and Z minus 3, they should go together. So you put them together.
I'll group them.
Yeah, and then Z minus 1, they have the same power. This one has positive, this one has negative, but we can group them together. Don't forget the 3's here. You just factor, when you factor out 3, you remain with this whole thing. And then from the formulas, you know that Z minus Z1, you see here, Z minus Z1 is equivalent to this one. Whenever there's a minus, it has to do with the sign.
Okay.
When it's like for example, you see here, minus, when you're subtracting two Z's, it has to do with the sign. If it's a positive, it has to do with the cosine.
Okay.
So, and then you have to also take into account the ends. In this case, the n is 1, so that's why here it's 1. 2i sine 1 theta. This case, it is 3 and it's sine. So the 3 will come here, and then it's going to be 2i sine. And then after that, it's just a matter of removing this minus 8 so that you only remain with sine cube theta.
Oh,
And you can see now the sign is in terms of k theta. In this case, the k is 3. In this case, the k is 1. So, and then we're done.
okay, now I'm not so confused as I was before.
You're confused now.
No, I said I'm not as
Oh,
confused as I was before. Yes, it's making sense now.
oh, that was a long session, eh? Was
It
it?
was.
We started what
It's like
time?
an hour.
Oh,
Started
it's
at
not
5.
bad. And I thought it was 2 hours. I thought it was 2
I
hours.
feel like I wouldn't survive 2 hours.
Oh,
I'll probably be
yeah.
like.
Yo. Yeah, it was.
And then
Where is
you
it?
said the matrices, right? We're gonna start this week, right? Because there's a
Yeah.
certain one that I want to start with because it's been
Oh,
bothering me that I haven't been able to
actually, we
get
have
it.
time, man. We have time. We can just clear up everything that needs to be cleared up before we even start matrices. Because, you know, we almost have like 20 days with the matrices. So we can just
So
not rush.
because yeah, I just want to like take in everything so that I don't like cram but also understand it because I think the ones that I've learned, they are the ones that I learned, but then the one that I've been struggling with is the elimination. The elimination always gives me problems, especially with the reduced row. And
You're talking about matrices. It's very important. Matrices, they count a lot, man. They have a lot of math.
mm,
But you know, with matrices, you know what I'm gonna do, you know? I'm
mm,
I'm just gonna we're just gonna do the basic stuff, all of it. How to
okay.
I will create a thing for you. I'll create a document. What we're gonna do. Like we're gonna start from the beginning, how to do
Okay.
reduced, and then we move on how to find inverse, and then we go on to find what is it? The Kramer what things.
Yeah, Cramer's rule.
Kramer's
And
rule.
I think there's also cofactor, I think.
Yeah, and those cofactors. You're just gonna do the basic stuff like, and then you're gonna come back and do the tricky stuff.
Yeah.
Yeah,
Oh, okay. Okay.
the tricky
Okay, I
stuff.
feel like I have more peace now because I feel like we started with the difficult stuff, which is nice because I got that out of the way. Then
Uh,
the matrices are not so difficult, but the way he did ask it was a bit tricky.
exactly. That's why I'm saying we're just gonna start and clear the basic stuff. Okay, remind ourselves how to find an inverse, how to actually I'll show you tricks so that you don't get stuck. Because sometimes when you're trying to do those things now, you come across like fractions, and
Mm,
it makes life difficult. So I'm gonna show you ways of how to do it without involving fractions.
okay.
Yeah, stuff like that, and then we're gonna come back and do these things where he puts cases and
Yeah, okay.
yeah.
Yeah, because that exam showed me flames, but it's fine.
Because
So,
those kinds of questions, they need you to understand like really what is going on with matrices. It's not just you finding the inverse. Uh, that's like basic. They need you to understand why are we. It needs you to study the book, really. Like Deep,
The book,
deep understanding.
I want to show you the book that I was using, but I'm not sure if it's the right one.
Which one? Yeah, you can just post it here
I think
on Telegram.
I don't even know how to do that.
You don't know how to
Do I? Okay, so I'm gonna find it. I'm just gonna send it if I still have it on my thingy.
is it the recommended
But I
book?
think it's the one that Evans.
Oh, let me
It's the
just,
one that's like orange-ish. Is it orange? No, I don't think it's orange. Let
I'm,
me just find it.
I'm using, I don't
I don't
buy
think it's gonna
books,
take
man.
me.
I use the ones online. Let me show you if it's this one. Let me just share my screen here. But it's like sharing, isn't it? Yeah, it is. Is it this one?
Yes, that one.
Yeah, that's the one.
Oh, I thought I used the wrong one because I switched. I switched to the other one, which was like the cover is black.
Yeah, this one is the what one? The PDF version.
Oh, okay, so okay, I'm gonna make sure to also go through that one because I did switch because I thought maybe I wasn't using the right one.
No, it's the same thing. It's just that this one is it's a PDF. It's an online PDF version, and then that one is a. I don't know. I don't know if you can, but I think that one is a hard copy. That's why the are you using hard copies?
No, not the hard copy.
No,
I
but it's the
also
same thing. It's literally the same thing. The difference is like
the
maybe,
same thing.
yeah, the difference is like maybe the exercises or the numbering of the exercises.
Oh, okay. Because I thought maybe there was a huge difference to it. Because
So,
mine, I think this one is, but it's the same person. But it's like the Australia and New Zealand edition, applications version,
oh,
12th edition. So I'm not sure it's different. It
hmm.
is,
Yeah,
I
just
thought.
use this
But
one.
it's
This
still
one.
by Whaley, but it's just a different edition.
Oh. But I doubted
Yeah.
I doubted matters which one you use because yeah. So basically we're gonna use this thing, this format. We're just not gonna go deeper in and then once we are done, we're then gonna come back and really understand what's going on.
Okay.
For example, we're gonna use Gaussian elimination and then matrix operations, show you how it's done, inverse, how to find inverses, how to, yeah, using this method. So that you can just, because it's not everything that's difficult. Some questions are just like basic questions. You just need to
Yeah,
know.
I think it's because like some questions are asked in another way. Because like I did study it, but then the way they asked the questions for the matrices was a bit tough, and I was like,
As
because
well.
I just like studied the bit of it, not like deep into it. So probably why it was a bit confusing.
Yeah, but you just
But
follow this routine. Diagonal, what is a diagonal matrix, metric transformation? Just get the basic stuff
mhm.
out of the way. How to determine a determinant using Cramer, and how do you determine a matrix without by inspection? I mean, how do you determine a determinant by inspection? All those things,
Oh, okay.
and then we're gonna,
I think
yeah, we're just gonna spend more time on these matrices.
okay. I'm just gonna also like at the same time also go through the work we went through so that I don't forget.
Yeah, you must try
And
and
then I'll just try more past papers because it's like starting to like, especially the one with the projection and stuff, it's starting to get drilled. So then I just try new questions and how they approached it and stuff. So I think I'm gonna be fine, hopefully.
yeah, I think you're gonna be fine. We're still gonna go back and like maybe the last week just get a paper
Mm,
and go through the whole thing again.
okay.
Maybe two past papers.
Yeah, I think that will be enough.
Yeah.
Okay, thank you very much. I think
Okay.
I'm gonna just go through all the information you gave me, and then yeah.
All right. And enjoy your
Okay.
evening. I'm just gonna try and pause this thing on YouTube. I think
Okay.
it's better that way. YouTube is much.
Oh, okay. Okay, no problem at all.
All right.
All right, bye.
Bye.